Alright, I'm going to be going over the test, Unit 7, Organisms and Their Environments. Number 1, students in 2 different schools created gardens at their campus. They only planted native plants. I'm going to circle the word native plants. That means naturally there. Plants naturally already there. Okay? That do not require extra care. Alright, that's key. The environment will take care of it. Environment will take care of them for the most part. Students from each schools were asked to sketch some of the native plants included in their gardens. Sample images from each school are included below. Prickly pear cactus. Ooh, cactus should remind you of a desert. Little to no rain. Okay. The pink butterfly flower. Okay, so it's a flowering plant. It needs water. Okay, especially more water than the cactus. Alright. Look, notice how I didn't focus on Canutillo Middle School, even though I know where this is at, and Olney Junior High, which I don't know where this is at. I don't focus on that. That's not my primary goal. Alright, I'm trying to get to the question. Which of the following characteristics, circle characteristics, of the garden environments pictured above has the greatest, has the most effect, okay? The most effect on the types of plants that grow in them. So we're trying to find out which of the following words, which of the characteristics, which of the descriptions, which of the qualities is going to make an effect on the plants in those gardens. Alright, and these are just samples. Okay, so if we kind of already found out that this is the desert and there's little rain, this one needs more water. We're really not sure where this is at. Maybe the prairie, maybe prairies, maybe open areas, maybe even near fresh waters, ecosystems. So let's look at our answer choices. A, temperature. All right, plants in the desert. It does get hot, it does get cold at night, okay? Would that deter, would that stop some plants from growing there? Yes, but overall the plants that are there have adapted to those temperatures, okay? What about this one? Would temperature do much? Sometimes they see extreme weather as well, but usually it stays pretty average temperature. So I don't think this one's going to do a big effect. Okay, the greatest effect. Remember our question, greatest effect on the types of plants in those gardens. Letter B, amount of rainfall. Is that going to deter, is that going to stop some plants from growing in this desert or some plants from growing in the prairies or the freshwater ecosystems? And I should just say forest or grasslands. Prairies or grasslands, excuse me. Amount of rainfall. Yes. Okay. So I'm going to put a question mark. Let's see if there's even a better answer. Letter C. Letter C says the amount of light. Pretty much if they're in the prairie, grasslands, or desert, it's open space. Okay, so they're going to get a good amount, especially if we're talking about Texas. Okay. We usually get sun year-round. It's not like we're in Alaska or in the northern parts of the hemisphere or the southern parts of the hemisphere where there's weeks, days and weeks where they don't see the sun. We're not in that situation. Letter D, space. Yeah, you might be limited in the garden for space, but is that gonna stop several of these plants from growing in the desert or the prairies or the grasslands? No. We're talking about the garden. specifically, but it says garden environment. So yes, they set up a garden at this school, but it's a desert ecosystem. It's a desert environment already. So the garden is just having those specific plants that can and have already adapted to that area. So space isn't a factor or isn't a characteristics. It's all about the rainfall. If we plant plants in this desert-like garden in at Canutillo Middle School, plants like this one can't grow there. Okay, you would have to be there all the time, adding and adding water. But right here in this paragraph, we said that do not require extra care. Okay, so we have to make sure that the plants that we plant here can survive with little to no rain. Over here, we need plants that do not require extra care. The environment is taking care of it. And one of those biggest factors, it is rainfall. Okay, rainfall. All right, number two. Number two, if your local environment begins to turn into a desert. So, do we have a clue what our local environment looks like? Nope. All right. But if the environment that we have turns into a desert, little rain, and we're going to say low biodiversity, what will most likely happen to the organisms, to the plants and the animals in the environment? F, the populations of organisms currently existing in the environment will increase. Okay, if we already went ahead and said little rain, then you're not going to have lots of producers. And your base for the energy pyramid is going to be small. Smaller than usual. Okay, so then the entire pyramid is going to be smaller. That means that your biomass, the total amount of organisms that you have, would decrease. So right here I'm going to cross it off, and my reasoning would be because it's decreasing. So F cannot be my answer. G, the populations of organisms currently existing in the environment will not be affected. Of course they are. You are changing from something, your local environment is changing, transitioning, turning into, becoming, changing into a desert. It will definitely affect. So this word right here is wrong. Okay? Will cause effect. Okay? What will cause an effect? The change. H. The new desert environment will be unable to support any populations of organisms. This is just absolutely not true. Okay? You know that in the desert we have snakes, we have cactus, we have beautiful plants that come out, we have salamanders, lizards, not salamanders, lizards, I meant to say lizards. There are insects, certain species of birds. So there are populations of organisms, but this question said any, and that's key word should throw off this entire question. There are species, all right? So I'm going to say animals and plants, or you could just say organisms, can survive in desert. All right, road runners and things like that. J, letter J. A different variety of organisms. Ooh, a different. Will be supported rather than the ones that currently exist there. Yeah. All right. You're gonna have a totally different you're gonna have totally different populations of organisms that already live there that cannot adapt in that short amount of time that it went from whatever environment you had, question mark, to the desert. All right. J's your answer. Number three. Which statement best, keyword best, describes the comparison between the lake, all right, that's freshwater systems, and, I'm going to put the word versus, saltwater, or ocean, saltwater. Ooh, so we're talking about freshwater versus saltwater ecosystems. Environments. Letter A. The lake and ocean environment support the same, same. Just cross out the word same. Organisms because they are both water, yeah, but they're different. They're fresh water without tons of salt. It has a little bit of salt, but not as much, as the salt water. And they are made up of the same elements. No, no, and no. A is completely wrong. Fresh water is different. Fresh water is different to salt water. Okay. B, the lake and ocean environment support different organisms. That's true. So far, this is correct. Because most freshwater organisms cannot live in salt water. Okay. Most. That's true. So I'm going to question mark it. All right. But we're looking for the best answer choice. The lake and ocean environment support the same organisms. This is not true. But they will look different because of the type of water. So it's telling me that if I have this sort of water in my cup and I actually bring in another cup with salt water, if I stick a fish in here or an insect, it's going to look different. That's just wrong. Look different. Really? No. All right. Letter D. The lake and ocean environment support different organisms. That's true. Because ocean organisms are blocked by land from getting into lakes. This is wrong. Okay? If you know about lakes, oceans, rivers, you know that there can be a lake that has a river that feeds into a ocean. That's all the case in Texas. Okay? We have the coastline right here, and we have the Gulf of Mexico. And actually, we have all these rivers that come in, and they have had lakes over here, or we even have gulfs, all right, with certain spaces. So, or we have bays, all right. The Trinity River is one of these rivers that feeds into the Gulf of Mexico. So, letter D is wrong. Best answer is B. Number 4, the Texas mock orange is a type of flowering plant that is only found growing naturally. Ooh, growing naturally. This reminds me like number 1 where we talked about native plants. In Texas, which of the following is most likely the reason that they only grow naturally in Texas? F, the type of animals that eat the Texas mock orange are not found in other environments. That wouldn't be a positive thing for that plant. Okay? So the plants would try to get out of the space that they're always getting eaten at. They wouldn't stay, they wouldn't stick in a place. They would actually adapt to those animals coming to eat them. So no. Alright? F cannot be the answer. Plants would adapt to the predators. Or to the, I should say consumers, not predators. G, the amount of sunlight the Texas mock orange amount of sunlight needs is not found in other environments. It's not the amount of sunlight. Okay? Sunlight usually the same. There's other areas around the globe. If you think about the entire world, and we're about at this location, okay? And this is the equator. All right. There's other areas around the world that have the same amount of sunlight. So why don't they grow in those areas? It says only they grow naturally in Texas, only found in Texas. So that can't be it. There's other areas of the world that get the same amount. Sunlight usually the same around this latitude of the world. H, the type and amount of water, the type of water and the amount of water the Texas mock orange needs is not found in other type of water. There's fresh water everywhere. G, the types of organisms that pollinate. Okay, types of organisms that pollinate and help the Texas mock orange reproduce are not found in other environments. That's a good one. If you have these organisms, plants or animals, that help pollinate, okay, bring pollen from other plants, and help it reproduce. If you don't have those organisms somewhere else, of course it's only going to stay in the area that it does have this pollinating help. Okay? So even though you might not know a lot about this question, or about this type of plant, this flowering plant, you should think about these other options. Didn't make any sense when you think about them. J is your best solution. Alright? It is very imperative, it's very important that you go through your answer choices and you make sure that if there's one part to it that doesn't make sense, cross it off, okay, and keep going until you find the best answer. Number 5. 4 students were asked to observe microhabitats of their schoolyard and describe how microhabitats are able to support different varieties of organisms. Their observations and responses are shown below. Okay, so the microhabitat was inside of a rotting log. They found termites, beetles, crickets, spiders. They described it as dark, cool, and damp. We have a grassy area along the curb. They found grass, flowers, clovers, grasshoppers. It was sunny, warm, and dry. Student number 1 said that the rotting log and grassy area are in different environments. Okay, different. Number 2 says the conditions for survival are different at each location. So this one was survival, this one was different environment. Number 3, the rotting log habitat has insects, but the grassy area doesn't have insects. There is more space in the rotting log than in the grassy area. Number 4, student number 4 said, which student best describes, best paints the picture, best tells you about how microorganisms are able to support, are able to hold, are able to help, are able to make it survive a variety of organisms. Okay? Which one best describes? So, I just want to point out that this one said the rotting log has insects, rotting log has termites, beetles, crickets. This part is correct. But the grassy area does not have insects. A grasshopper is an insect. It starts off with eggs, it turns into a nymph. The nymph is a baby adult, and it just grows in size until it gets to the adult size. So number 3 is false. It's a false statement. Okay? Number 4, there is more space in the rotting log than the grassy area. I don't know about that. This one's a question mark. How big is the log? It can be a short log, it can be a long log, I don't know. The grassy area, we don't know how small the curb was or how big the curb is. Okay? So those two are kind of iffy. Number 1 says I'm going to go ahead and cross off C because it says student 3. Student number 1 says the rotting log and grassy area are in different environments. But if you remember up here, it told you that 4 students were asked to observe microhabitats of their school yard and describe how the microhabitats are able to support the different varieties of organisms. Their school yard. I don't think the schoolyard is very large, over acres and acres and acres, over states, over even countries. okay, where you could possibly be in a different environment. All right, so number 1 is a false statement as well. Okay, so I'm going to cross off A. So now we're left with 2. The conditions for survival are different at each location. So let's take a look again. We have dark, cool, and damp, so you got to survive in this area, versus sunny, warm, and dry. Damp means that that it's humid, okay, that you can feel that there was water droplets at some time, or there may be still some water droplets in there, but maybe some of it is in the air. All right, it's been evaporated, but you can still feel the humidity. Versus it's dry along the curb. So these two microhabitats are different, and number 2 is true. So I'd pick number 2, because even if you left number 4 with a question mark, it's kind of like, what's the size of the areas of the microhabitats? He kind of or she kind of left it up in the air. Okay, so I would not pick 4 just because there's uncertainty. Okay, you're really not sure, but 2, you're sure. They're different. Okay. Number 6, a student rolled over a wooden log and made the following observations. Observation number 1, a millipede eating small pieces of wood that have broken off of the log. Number 2, a salamander scurried into the shadow of the log's new location. Number 3, 3 types of mushrooms are growing on the log. Number 4, observation number 4, a variety of smooth rocks are pressed into the soil. So we have observations. Which observation, which view which observations support the student's claim, the student's argument? What are they trying to get across? That the log represents a microhabitat. Okay, remember, a microhabitat is a small living area with its soil, temperature, rainfall or rain, something about water. Okay, so let's see. Number 1, a millipede eating small pieces of wood that have broken off the log. So now we have a food source, right? So anything with number 1 should stay in the game. Oh, Jay's out of the picture. All right. Number 2, a salamander scurried into the shadow of the log's new location. So there was shade. All right. It was dark, and that's what they needed. So 2 stays in there. All right. Number 3, 3 types of mushrooms are growing on the log. That's very important. You have decomposers already there. Something's going on. That is that's an organism that's also participating in it. So anything with 3 should stay in there. F doesn't have, missing number 3, and H is missing number 3. So we end up having G as our answer, but let's read 4. A variety of smooth rocks are pressed into the soil. That doesn't have anything that's contributing to the microhabitat, whether there was rocks or not. Okay? It's not contributing. All right. Number 7. Students created the table below based on observations of 2 microhabitats near the school. Inside a rotting log, termites, beetles, cricket spiders. The characteristics: dark, cool and damp, grassy area along the curb, grass, flowers, clovers, grasshoppers, sunny, warm, and dry. Very similar to the other question. Based on if not, it's the same. Based on the information above, what is the best explanation for the different variety of organisms in the 2 habitats? So why do they have different animals? Why do they have different plants? Okay? So A, the rotting log and grassy areas are in two different biomes. Remember, biomes are large regions, large ecosystems that cover large regions. That one, boom, out. All right, remember we studied biomes. Those are the marine biome all around the world. That is not a small area where you could say it's a microhabitat. No. B, the conditions for survival are different in each. One of them's sunny, one of them's dark, the other one's warm, the one's cool, one's damp, the other one's dry. The conditions are for survival are different. That's true, question mark, but we're looking for the best. The rotting log has predators while the grassy area does not. The spider could eat some of these other ones. But you have the grasshopper eating the grass, the flowers, even the clovers. So that's not a good explanation. Letter D, there is more space in the rotting log. Again, this space thing, the space issue. You cannot zone in and think, oh, the curb is this small and the log is very small. Okay? Maybe the curb was really small, but then the log was longer. It really doesn't matter because at the end of the day, you have to go with which one makes more sense. And of course, we're talking about survival. B. Number 8. Oh, number 8's really easy. But just in case you missed it. The more diverse, the more biodiversity an ecosystem has or is, the more diverse an ecosystem is. Biodiversity. Okay, biodiversity increases. That means something. The more threatened its population is, nope. More threatened, no. The more safe. Okay, the more similar the species will be. No, biodiversity means different organisms, different living things. Okay, the more sustainable it is. Yes, sustainability. It will sustain the ecosystem. Sustainability will increase as well. You will have organisms supporting this entire ecosystem. Question mark. H. Letter J. The fewer varieties of species present. Nope, that's what it means. Biodiversity. Different living organisms. And if we're increasing this more right here, then you're going to have more varieties. All right? So our answer ends up being H. Number 9. Right? Number 9. We have two food webs. We have a prairie food web and we have a tundra food web. Refer to the food webs above if the grasses in each ecosystem are attacked or killed by a disease, which ecosystem will most likely survive. Alright, so let's take a look. Let's find the producers. One producer. Nope, that's only one. Right here we have grass, we have lichen, and we have moss. So if we take out the grass, which one will survive? The one that has more producers. Which one has more producers? Of course, the tundra. This one's the winner. Okay? So the prairie ecosystem, because it has fewer organisms, eat grass. Nope. The tundra ecosystem, okay, so far good, because there is a variety of producers. Yeah, they have the moss and they have the lichen. Okay? Question mark. The prairie ecosystem, no, because there's no. The tundra ecosystem, because there's more herbivores, no. This goes back to the question about if you have a bigger base, if your triangle base is this small, then your energy pyramid's going to be that small. Well, this one's going to be larger. The more that you have, the more producers you have, the more sustainable, the more biodiverse that it is. All right, number 10. Which statement below best describes how biodiversity contributes to sustainability of an ecosystem? So how are these two words connected? Okay, a variety of plants and animal species allows for more survivals of a natural disaster. So if you have biodiversity, you will survive more. You will be more sustainable. after a natural disaster? Question mark. Yeah, that's a great definition real quick. Right here. Having more species in an ecosystem allows the human population to increase in size. We don't need every single organism. So if we had some of those organisms we don't eat, would our population increase? No, it would stay the same. Low biodiversity reduces the competition for resources. That's true, which helps native species survive. Not really. It doesn't answer the question about sustainability. How does biodiversity help with sustainability? It sustains native species? Yes, but then at the same time, you don't have a large variety of species. Okay, native species are a part of the biodiversity. So this answer choice doesn't answer the question. Kind of confuses us. Letter J, fewer species in the ecosystem reduces the likelihood that disease spreads through the ecosystem. That's not true. Okay, it actually the less amount of species that you have, this actually increases the likelihood, because if you only have 5 organisms and you have a disease that attacks 1 or 2, then you're left to 3. So the fewer that you have, your chances increase. So your answer ends up being F.